Hey guys, it's Miss Adams, and we're going to keep looking at the Unit 10 test review. So we're on problem 6, and problem 6 talks about identifying the value that completes the square. So we're looking for that b over 2 squared term for the following expression. So you guys probably saw some like this on your Delta Math. So for problem A, I want to look for my b value. And in this case, it is 6. And I know that 6 divided by 2 is 3. And 3 squared will give me 9. So the value I'm looking for here, my perfect square value, is 9. For problem B, I know that my b value is negative 12. And negative 12 divided by 2 is going to give me a negative 6. And negative 6 squared is a positive 36. So that will be the value that I would add inside my parentheses. For problem C, my b value is 16, so I'm going to do 16 divided by 2 squared. 16 divided by 2 is 8, and 8 squared is 64. So my perfect square value is the number 64. And for D, I'm going to be looking at my b value of negative 14. Negative 14 divided by 2 is negative 7, and negative 7 squared is a positive 49. So my perfect square value there is 49. Now let's go on to problem 7. This is going to be an error analysis. So we know that Max has been working hard on solving this function and trying to complete the square. So he's trying to go from standard to vertex form. But we got to see where he went wrong. So Max was working this problem by completing the square. He made a mistake. Identify his error and then correctly complete the square. So looking through this, I see Max started off with x squared plus 12x plus 36. Or excuse me, plus 3. So this was the initial function, x squared plus 12x plus 3. Then Max went through, and although it doesn't show his work fully, I know he'd have to do b divided by 2, so that's 12 divided by 2 squared. Well, that gives him 6 squared, which is 36. So his perfect square term is 36. So I see that Max added 36 on the inside of the parentheses. But guys, we can't just add things to equations. If I add something, I must also take it away on the outside. But it looks like Max made an error here because he added it on the outside. So our error then comes to our k value. So let's rework this to where there's not an error. So originally, Max did get this part right. He had x squared plus 12x plus 36. But on the outside, he should have plus 3 and then minus 36. So he's got to take away that perfect square value. That's going to simplify to x squared plus 12x plus 36. Then on the outside, he'll have minus 33. And this is a special trinomial here. I know that I can factor it then to say x plus 6 squared minus 33. So this would be the correct vertex form. And his error was that he added the perfect square to the constant instead of subtracting. Which leads us to our last problem. So Sophia and Riley have had an argument over these two different examples of quadratic functions. Neither of them can figure out which one has the largest y-intercept. Sophia is looking at our problem A here, and Sophia thinks that A has the larger y-intercept, while Riley is looking at problem B, and clearly Riley thinks that B has the larger y-intercept. So let's see what we have here. Well, in order to find the y-intercept for A, we're going to use box distribute and add. So I got to go from vertex to standard form. So my first step is to use the box method. And I'm going to multiply x minus 2 by x minus 2. That's going to give me x squared. Negative 2 times x is negative 2x. X times negative 2 again is negative 2x. And negative 2 times negative 2 is a positive 4. I'm going to combine like terms diagonally. So that'll give me x squared minus 4x plus 4. But I still have that positive 1 behind my parentheses. I don't have anything to distribute. So my last step is just to add. So my standard form is x squared minus 4x plus 5. So therefore, the y-intercept of A is 0, 5. And then if I go over to B, I look for its y-intercept, and that's at 0, 6. So therefore, problem B has the greater y value because the value 6 is greater than the value of 5. And guys, that is everything that is going to be on your Unit 10 test. Thank you so much for watching, and I hope you guys do great.